Hey guys, this is Fraser from Smart Tutoring here. Today we're going to be looking at this HL, it's specifically HL, paper 1 integration question. It's 6 marks, so it's kind of a, it's worth quite a few marks and it's not too much work, but it's a bit of a different question. So they actually give us the substitution, which is nice. They say by substituting u equals sec x or otherwise, so we're not limited to that method, we have to find an expression for this integral over here. So it's integral from 0 to pi over 3 of sec to the power nx times tan x dx. And we have to find it in terms of n, where n is a non-zero real number. So a quick reminder, sec x is just the reciprocal of cosine of x. And so we're just going to go straight as, we're going to try and rewrite this integral in terms of u. So what we have is, if u equals sec x, that means that du dx equals sec x tan x. Now this is one of those that you can either remember or you could do a chain rule, because you know that u is cosine x to the -1, so you could do it like that. But I believe it ends up being sec x tan x, and that's just one of those ones you see so many times you remember it. So that means that du is going to be sec x tan x dx. So that means in the integral, what we can rewrite it as now is, and one last thing actually, change of limits. So that means that when sec x, when x equals pi on 3, cos x is going to be, so when x equals pi on 3, cos x is going to be 1/2, so that means sec x is going to be 2, so that means u is going to be 2, and when x is equal to 0, cos x is 1, so sec x equals 1, which is equal to u. So we change the limits to 2 and 1, and then what we have left is sec to the n-1 x times sec x tan x dx, but this whole thing is just du, right, from over here. So this becomes the integral 2(1) sec n-1 x du, and remember that sec x equals u, so sec to the n-1 x equals u to the n-1. So that means that bringing the entire thing into u, that means that it's u to the n-1 du. This is not too difficult. You just do the normal integration with, we're just adding 1 to the power and dividing by it. So if we add 1 to the power and divide by it, that's going to be u to the n divided by n at 2 and 1. So that's going to be 2 to the n minus 1 divided by n. And that's the final answer. So it's 6 marks, it's quite a lot of marks, and it's not super difficult. It's just a bit different because now we're sort of finding an integral, like a formula for an integral, because if it's in terms of a variable n. But the fact that they give us the substitution makes this quite a bit easier. Just to reiterate, this is a HL question. SL candidates don't need to know about reciprocal trigonometric functions, but it still could be a useful question for SL as well, just to see what some of these harder questions look like. So hopefully that was helpful. If you guys feel like you need more help like this, feel free to head over to the I think Smart Tutoring. The link is in the description. You can grab a tutor there. It's super flexible, and maybe if you need to do a bit more practice for your exams, or you just want to get your predicted grades up a bit, then it might be a good idea. But yeah, feel free to do that. I'll be making more of these videos, and see you guys soon.